Welcome to Sundar's lecture. This is lecture number 36, and in this lecture we are going to see AC through pure inductor, which means we are going to give an AC supply to the pure resistor, and we try to find what is the power that is delivered in this particular circuit, right? So what are all the topics we have seen in the last class? See, we have seen what is a polar and rectangular form of an alternating quantity, and how we can write an alternating quantity in rectangular form or in polar form. For example, we have taken a numerical problem, and in that numerical problem they have given you the general form of AC quantity, and we have taken Im and pi values, and we have found what is the rectangular form and what is the polar form, right? This is how you can write the AC quantities, right? So from here also you can find what is the polar form. That is also it is easy to find. For example, they have given you like this. For example, they have given I is equal to 14.14 at an angle of 45 degree. See, this is in polar form, and you can easily convert that polar form into rectangular form by writing I 14.14 cos of 45 degree plus j 14.14 sine of 45 degree. And if you simplify this, you will get this value. That is obviously you know from this part. But also, if they have given you like this, which means 10 plus j 10, if you want to convert this in this rectangular form value into polar form, then also it is very simple. See how you can find that value. See, for example, if you want to find what is the I should be is equal to what? IRMS. That means modulus of IRMS at an angle of pi, right? So how will you find modulus of IRMS? That the formula to find this value we have already seen. That means x square plus y square, right? And what is x square and what is y square? What are all the things we have seen? What is x and what is y here? This is the term, right? And what is x here? That is nothing but this value. I cos pi is the x value, and I sin pi is the y value, right? We have seen this already. That is what we have taken it as modulus of I, which means we are always right the values in the RMS value if it is an alternating quantity. So it should be x square plus y square. We have seen this one already, right? So it is very simple to write. How will you write? This will be square root of 10 square plus 10 square, right? So what will you get? This will be 100 plus 100, 200. Square root of 200 value of square root of 200 will be 14.14 amperes. And what is pi value? Pi value can be found by, this is nothing but I RMS, that means modulus of I. Pi value can be found by tan inverse of what? Y by x. That is also we have seen, right? That is also we have seen already. See, tan pi will be is equal to, sorry, pi value will be is equal to tan inverse of y by x. That is also we have seen. And if you go for pi, which is equal to tan inverse of what is y here? Y, which means it is a 10 here, and also x is 10. So 10 by 10 will give you 1. What is tan inverse of 1? That is nothing but it is 45 degree, right? So pi will be is equal to 45 degree. So how will you write this one right now? So this is the modulus of RMS value, and this is the value of pi. So I will be equal to 14.14 at an angle of at an angle of at an angle of 45 degree amperes. Right, you see from here, that means from rectangular form, we have converted this value into polar form. This is nothing but polar form, right? We know this is polar form. This is polar form. See, you can convert both ways, right? See, from here you can get this one, this rectangular form by this formula, and from here you can get this one by using this formulas, right? So you try to understand these kind of things. Okay, now in this class we are going to see AC through pure inductor. Before that, you need to know certain basic things to understand what is the power in an AC circuit or power in any circuits, right? So how you can easily understand? See, if you take, this is the source. Let me draw the diagram. see I have taken a source and a load, and what is positive power and what is negative power. That is what we are going to learn. See, if power flows from source to load, which means power will flows from source to load. If this is the case, then these powers are considered to be positive powers. Positive powers, right? Now, in the other case, if power is flows from load to source, if power is flows from load to source, then those powers are considered to be negative power. Negative power. You try to understand this concept is very important to understand what is real power and what is reactive power. Try to understand, if it is a real power should be positive. That the thing you have to understand, always a source should deliver power to the load. If that is the case, then the power is called as real power or active power. At the other case, if load is deliver power to the source, that is negative power, and that power will be again delivered to the load. Again, this load will deliver the same power to the source. So those kind of powers which are not utilized by the load as well as by source is called reactive power, and we will see that one. We will see. Just you by now you try to understand that is positive powers are the powers which are delivered by the source and absorbed by the load. That means power flows from source to load. That's all. And what are the negative powers? Negative powers are power delivered by the load and absorbed by the source, or not absorbed. It is not like that. From load to source, we can consider that as negative powers, right? You try to understand these kind of things. Now, what I really want to understand here, and you see, if it is a resistive circuit, purely resistive circuit, if I am giving V is equal to Vm sin omega t and resistance, this is R, actually this is resistor R, and I need to find what is Im, what is the value of I. We know, right, what is the value of if you want to find I, we know V is equal to Vm sin omega t. I have written here directly anyhow. I have written here Im sin omega t, but how this I is coming, I'm just going to derive this one. So we have given R, resistor R is already given, which means resistor which is equal to R is given. And what is the formula for I? I should be is equal to V by I, right? We know this formula. And if you want to write what is V here, Vm sin omega t divided by I. And I can write like this, right? Vm by I sin omega t. Sorry, V by R. This is actually R. This is actually R. And also this is actually R. So this will be omega t. And what is Vm by R? Vm by R, that I can write it as Im. That's all. So what is I here? Im sin omega t. And what is Im? What is Im? Im will be equal to Vm by R. Right? See this one. This is the value of I. That is what I have written here. Anyhow, what is the maximum value of Im? That will be always low, less. If resistor is a whole number, then obviously Im will be less value when compared to Vm. When compared to Vm, right? So that you have to understand. So what is V and what is I? We can easily understand here. And you see both V is equal to Vm sin omega t and I is equal to Im sin omega t. There is no pi. Pi value is 0 here, which means the phase angle between V and I is 0 in resistor, in the resistor circuit. So How can you draw the phasor diagram? What is the phasor diagram? See, I will draw the phasor diagram. For example, if this is the V, if this is the V, if there is no phase angle, and what happens to Im? If for example this is Vm and this should be what? Im. This should be Im. There is no phase difference. There is no phase difference because both are in the same phase. Because there is no phase difference. If we will get always V is equal to Vm sin omega t, but I is equal to I am getting Im sin omega t. There is no phase difference, right? So this is how you need to find this value. And now I try to find the value of power. How will you find the value of power? Power. See, power P, which is equal to V into I. We know this formula, right? So P, which is equal to, what is V here? V will be Vm sin omega t and I will be Im sin omega t. So this will be Vm sin omega t into Im sin omega t, right? So if you find this value, and what we can do here, P, which is equal to Vm Im sin square omega t. I can write like this, right? Sin square, because two sin thetas, sin omega t are there, so I can write like this. So, so what is sin square omega t? Sin square omega t can be written as 1 minus cos 2 omega t divided by 2, right? I can write like this. So now what I can do? P, which is equal to, or I can write it in a different color. P, which is equal to Vm Im by 2, this value will be 1 minus cos 2 omega t. This is the final power value. And if I want to get what is the average power, that what we can do now, let me do one thing. I just want to draw the graph and I need to substitute the omega t values. Try to understand. So that you can easily understand how power delivered in this particular circuit, right? What we do now, we try to substitute omega t values and we try to draw the graph. Okay, fine. You see, I have taken this graph. I have drawn a graph for this particular expression. That means Vm Im by 2, 1 minus cos omega t. See, I have taken omega t is equal to 0 to 360 degree with 45 degree split ups. And I have also written the values for every split ups, which means every 45 degree, I have calculated the values. I have taken Vm Im by 2, 1 minus cos, and instead of omega t I have substituted 0 here. So 0 into 2 will give you what? 0. So cos 0, what is the value of cos 0? Cos 0 is 1. So 1 minus 1 will give you 0. So 0 into anything will give you 0. So at omega t is equal to 0 degree, you will get the value will be 0, right? So I just try to mark it down here. So at omega t is equal to 0 degree, the value of this expression will give you 0, right? So if it is 45 degree, so Vm Im by 2, 1 minus cos 2 into 45 will give you 90. So what is cos 90? Cos 90 value will be 0. So 1 minus 0 will be 1. So Vm Im by 2 into 1 will give you Vm Im by 2. So at 45 degree, the value will be Vm Im by 2. So at 45 degree, the value will be Vm Im by 2. So it will come around here, right? So next one, like that, if I go for 90 degree, it will become 180 degree. What is 180 degree? Cos 180 degree will be minus 1, and 1 minus of 1 will give you 2. So this 2 and this 2 will be cancelled out. The final value will be VMIM, right? So at 90 degree, I will get VMIM. So at 90 degree, I will get VMIM, right? So if I substitute like that, at 135 degree it will be VMIM by 2. So at 135 degree it will be VMIM by 2. It will come here. And then at 180 degree it becomes 0 because cos 360 will give you 1, that will be 1 minus 1 will give you 0. So it will come around here. And then at 225 degree, you see it will be 1 minus cos of 450, that will give you VMIM by 2, right? So VMIM by 2, again it will be here, and at 270 degree, so I just put down here. So at 270 degree, it will be VMIM. You just substitute these kind of values, you will get these values. And at 315 degree, it becomes VMIM by 2. This will come around here. And at 360 degree, it becomes 0, right? It will be 0. See, if I connect all these points, if I connect, so I'm just connecting down, it will be like this. Okay, fine. See, one thing you need to understand here. See the power. This is the power curve, right? This is the power curve, which is getting 0 here, and at this point it is getting maximum value, and at this point again it is getting to 0, and at this point again it is getting to maximum, and at this point again it is getting to 0, and this cycle will repeats again, right? This will be repeating again, and you see all the power values are positive. Try to understand, there is no power is coming like this, right? If it is like this, then those kind of powers are called as negative powers. So what I have told you already, what is the thing we have seen here? What is the positive power? The power which flows from source to load will be positive power, and we can call that power as well as real power. So if it is a resistive circuit, see, all the powers are getting positive values. So these powers are all real powers. Real power, right? Real powers, which means these powers are delivered from source and absorbed by load. There are no power coming from load to source. That you need to understand very clearly, right? Now, what is the average value? See, you don't need to go for expression or to integrate this expression. If you integrate this expression for average power, then also you can easily find the values. Anyhow, by seeing this graph itself, you can easily find what is the average power, right? What is the average power? See, this is the 0 point and this is the maximum point. You know what is maximum point. VMIM is the maximum point and 0 is the minimum point, and every powers are in positive. So you see, what is the average power? Maximum VMIM minus 0 divided by 2. See, average power can be written as what? P average. We can easily find, right? How we can write this one? What is the maximum power? It is VM IM minus, what is this value? 0 divided by 2. And what is this one? VM IM by 2. That is the average power, right? That is the average power, right? So you see, what is the average power? That will be is equal to VM IM by 2, or you can write like this, right? VM by root 2 into IM by root 2. I'm just writing like this. And what is VM by root 2? What is VM by root 2? VM by root 2 is which is nothing but it is VRMS, right? We have seen this. What is RMS value? That is nothing but maximum value by root 2. So how I can write this expression right now? It is simple. See, this should be equal to VRMS into IRMS. So I can write P average, which is equal to VRMS into IRMS. See, it is not necessary to display Vrms and IRMS in an AC circuit. See, wherever you see any V and I separately, then that should be a RMS value. That should be RMS value. It is. We have seen this one. We have already discussed these kind of things already, right? So this will be the average value. So P will be is equal to V into I. Defaultly, you have to understand this. This is the RMS. These two are in RMS value. Unless if it is not given anything, that means VM, IM or anything else, then you have to understand that should be the RMS value. Anyhow, this expression, by integrating this expression with 0 to 2 pi values, you can easily find the average value, that is nothing but it is Vm Im by 2. By mathematical expression also, you can get this value Vm Im by 2. By deriving the mathematical expression, you can get this value. But anyhow, I don't go for mathematical expression unless if it is not a graph. See, if you have a graph, then you draw the graph and try to understand things from the graph itself. So you see, now you can clearly see this one. See, if you take any books, they will write 1 minus cos 2 omega t will always positive values, will always gives you positive values. See, you draw the graph, put omega t as 0 or 45 or up to 360, you draw the graph and see that it will be the positive value. Then it will be a clear idea. You can easily understand, right? So, a pure resistor circuit, which means a pure resistor circuit, will always gives you real power, only real power. That is the point you have to understand, right? So we will continue in the next class with the AC through pure inductor and pure capacitor in the future classes, right? Thank you. You go through this, you will get an idea.